Good morning. I am Dr. Jyoti Kumar. Today we will discuss about the topic compiler. Compiler act as a translator. It transforms a human-oriented programming language into computer-oriented machine language. Here we are giving source program as an input to a compiler, and it generates a target program. Normally, a program written in a high-level programming language is a source program, and this program is going to give as an input to a compiler. It generates a target program. What is a target program? It's actually a machine code or relocatable object file. If this target program was not attained by a compiler, then it throws an error. This is a pre-processing technique. Here we are giving a program, C program as an input to a preprocessor, and this preprocessor is going to pre-process the given input. C program is a high-level language, and this high-level language given to the preprocessor generates a pure high-level language, and this pure high-level language is given as an input to a compiler. If there is any error, then again it moves to process to the preprocessor. Here, once this compiler is giving a program, this is an object code. The output of a compiler is an object code, and this object code is given to a loader and linker. It generates an executable code, and this executable code is given to the memory and then to the processor. It generates the output. Coming to the major part of a compiler, we have two parts of a compiler. One is analysis part, other one is a synthesis part. In analysis phase or in analysis part, we have this is intermediate representation is created from the given source program. We have a lexical analyzer phase, syntax analyzer phase, and intermediate code generator phase, or the part of this phase. Analysis part. When I come into the synthesis part, the equivalent target program is created from this intermediate representation. We have a code optimizer phase and a code generator phase, or the two parts in the synthesis part. Here, this is a compiler. We have two parts: analysis part and the synthesis part. Analysis part, we are giving a source program as an input, and synthesis part, we are generating a machine language program. Here, this is an organization of a compiler. The first, we are going to give a source program as an input to a lexical analyzer part. It generates a token. We can call the lexical analyzer as a scanner, and this token is given as an input to a syntax analyzer. It generates a parse tree. We can call the syntax analyzer as a parser, and this parse tree is given to an intermediate code generator. It generates an intermediate code, or we can represent as intermediate code representation. This is given to as an input to code optimizer. It optimizes the code, and this output of code optimizer is given to a code generator. It generates a target machine code. And we have a symbol and attribute table here, and this is connected with all the phases of a compiler. Once it was generated right from the first phase, the simple table, we have a certain representation or addresses for the particular identifier. And again, we have this simple table is connected with each and every phase of a compiler. So this is the input, position equal to initial plus rate asterisk 60. So this is the stream of characters which I'm going to give as an input to a lexical analyzer or scanner. It generates a token. The token is represented as ID1, which is equal to ID2 plus ID3 asterisk 60. So this token is given as an input to syntax analyzer or a parser. It generates a parse tree. So this parse tree, this is the diagrammatic representation of a parse tree. We have a root node in the middle of both the attributes, asterisk, plus, equal are the root nodes, and these are all the values, id3, id2, and id1, and this is 60. And this is given to a semantic process or semantic analyzer. It just represents the type checking, or if you need to convert the value integer to float or integer to real, it generates it. This actually here we are giving this position equal to initial plus rate asterisk 60 to a scanner. It generates a token, and this actually we are using a regular expression is to describe the value of a token. This regular expression is given to a finite automata. It generates a token. So we are introducing regular expressions and finite automata for the lexical analyzer. Coming to the parser, this is the input we are giving to a parser or a syntax analyzer. This parser is going to validate the given input, whether it is going to be parsed or not. And here in parser, we are going to introduce context-free grammar. So once this given input value is works with this context-free grammar inside the parser, and it find out whether the given input string is valid or not. If the input string is valid, then it generates a parse tree. If input string is not valid, it does not generate a parse tree. And after the semantic analyzer part, it is given to as an input to the intermediate code generator. It generates an intermediate code. The intermediate code is nothing but a syntax analyzer or a 3-address code, or we can say infix and postfix and many. It generates an intermediate code something like this: temp equal to integer to real of 60, converting based on semantic analysis. Integer to real of 60, and temp equal to id3 asterisk temp1, and temp which is equal to id2 plus temp2, this part, entire part, and it is equal to temp3. And this is given to the code optimizer. Probably it optimizes the given code. Even if the code optimizer is not here in this part, then probably we can able to directly move to the code generator also. So code optimizer is not it optimizes the code, but it is not mandatory to be present here. And this code generator is going to generate the target mission code for the given input code. So this is the parts of or simply phases of a compiler. The first phase, the given input as a source program, and the first phase generates the output as a token from the lexical analyzer. This token is given as an input to a syntax analyzer, generates a parse tree. And this parse tree for a semantic is given to a semantic analyzer, generates it just look at the type checking, and this parse tree is given as an input to intermediate code generator. It generates an intermediate code, and this intermediate code is probably given to the code optimizer. It optimizes the code. If not, it directly given to the code generator. It generates a target mission code. Coming to the lexical analyzer, what is lexical analyzer? Lexical analyzer reads the source program character by character and returns a token as a source program. A token describes a pattern of characters having some meaning in the given source program. So this is the input we are giving, int val which is equal to old val plus 12. So when I'm giving this as an input, so it generates a token. What is a token here? So input val, this input val is an identifier, and this equal is an assignment operator, and this odd val is an identifier, and this plus is a operator, addition operator, and this 12 is a number. So all the entire thing we can call it as a token. Token can be of different types. One is called as an identifier, assignment operator, identifier, add operator, a number or a constant we can say. So the entire thing, and I can call it as a token. Puts information about the identifier into a simple table. This information about the identifier alone in a simple table. The regular expressions are used to describe a particular token. As I mentioned, we have a regular expression. This regular expression is given to a finite automata to implement a Lexical analyzer. So we have finite automata, and the regular expression is given to the finite automata. It generates a token. Coming to the syntax analyzer, as mentioned, it's a parser. It creates a syntactic structure of a given program. Syntax analyzer also called as a parser. This is the structure of a parse tree. Syntax analyzer. Syntax of a language is specified by the context-free grammar. The rule of a context-free grammar are mostly recursive. As mentioned earlier, so the input is a token for the syntax analyzer. So I'm going to validate the given token whether it is parsed or not. To validate the given token, I need a context-free grammar in the syntax analyzer part. So the syntax analyzer check whether the given program satisfies the rules implemented by the context-free grammar or not. If it valid, then it generates a parse tree. If it does not valid, it does not generate a parse tree. Coming to different type of a parsing technique or parser. In the syntax analyzer part, we have a top-down parsing, we have a bottom-up parsing. Two types. In both the cases, even top-down parsing, it is going to validate whether the given input string is parsed or not. And similarly, for bottom-up parsing, again, it is going to check whether the given input string is parsed or not based upon the context-free grammar. Coming to the top-down parsing technique, the construction of a parse tree starts at the root node and proceeds towards the leaf. We have different types: recursive descent parsing, predictive parsing, and LLF1 parsing. Coming to the bottom-up parsing, the construction of parse tree starts at the leaf node and proceeds towards the root node. We have a different type of bottom-up parsing technique: shift reduce parsing, operator present parsing, and allow parsing. In allow parsing, it is of different types. One is SLR, CLR, and LALR. And semantic analyzer, as I mentioned earlier, it is just going to find out. It is a type checking. It's an important part of semantic analyzer. It is going to check the type, and it is going to represent in this. Coming to the intermediate code generator. So this is the given input string. It is valid based upon the parse tree. Then this parse tree is given as an input to a intermediate code generator. It generates an intermediate code like this. Multiply id2 and id3 and put in temp1. Add temp1 and 1 and put in temp2, and then move temp2 to id1. So this is an intermediate code. Again, code optimizer. It optimizes the 3 or 4 line codes into 2-line code. So it optimizes the given input intermediate code.